Hi everyone, this is John again with InventorCAM Professor, and I'd like to welcome you to another Getting Started series for iMachining. In this series, I'll show you how InventorCAM's iMachining technology is used to define the machining of a bracket. In addition to the iMachining toolpaths, you'll see standard 2.5D toolpaths as well as 3D toolpaths to aid in the complete CNC programming of this part. Now, like the previous Getting Started exercises, the machining will be performed on a 3-axis CNC machine. For this example, however, you'll see that 2 setups are used to machine both sides of the part. All operation definitions are completed. I'm just going to run through those definitions with you, and we'll take a look at the final toolpath for each of the operations. So let's go ahead and get started. I already have the part opened and ready to go. So you'll first want to open the example InventorCAM part that's provided with this series of videos. The part file called IVIM bracket can be opened directly from our interactive guide. If you're otherwise viewing these videos from the InventorCAM website, you should have downloaded the part file and saved it to your computer in a preferred location. Once it's downloaded and saved, you can go to the InventorCAM 2015 tab of the Autodesk Inventor ribbon and click Open. From the CAM Parts dialog box, browse to the file location and open it. I should mention that there are 2 part files included with this series of videos. The first file, which happens to be the one we are reviewing, includes the 3D operations used in the programming. If your CAM package does not contain the required 3D modules, and you would like to view the CAM part without 3D operations, then you should open the second file called IVIM bracket no 3D. Once the part is opened, let's take a look at the CAM part definition first. The CNC machine controller is selected to post G-code for a 3-axis HSS. 2 coordinate systems are defined for all iMachining, 2.5D, and 3D operations. The stock and target models are also defined. And finally, we can see that the iMachining data is defined. HSS new is chosen for the machine with a default level of 6, and aluminum with a 100 Brinell hardness number, and a hardness Rockwell of 60 on the B scale is chosen for the material. The machine and work material parameters are used in iMachining calculations. Let's go ahead and click Cancel to exit the CAM part definition. When prompted with the message, "The part data has not been saved. Do you want to exit?" click Yes. In looking at the InventorCAM Manager, these first 2 iMachining operations perform the outside shape machining. Let's first take a look at the roughing operation. Double-click iRough outside in the CAM tree to open the iMachining operation dialog box. By clicking the Show button on the geometry page, we can see that 2 chains are defined, with the first being the stock boundary and the second being the profile around the part. The stock chain is marked as open, which specifies that the tool should approach from the outside and collapse in towards the part profile. Go ahead and exit the Show Geometry dialog box. By switching to the tool page, you'll see that this operation uses a 1/2-inch diameter end mill. On the Levels page, we have a -25 thou delta depth, so the tool machines a little bit deeper than the part bottom edge. On the Technology Wizard page, we can see the cutting conditions calculations based on a machining level aggressiveness of 6. And by switching to the Technology page, you'll also see that this iRough operation will leave a 10 thou allowance on the walls. Let's click Simulate to take a look at the iMachining toolpath at work. Using the default HostCAD mode, set your desired simulation speed and click Play. During simulation, the corners are cleared first, and then the entire outside contour is machined. Now switch to the Solid Verify tab and click Play again. Now we can watch the tool moving through the solid stock material. Let's exit the Simulation Control Panel and take a look at our next operation named iFinish Outside, which is defined to perform the finish machining of the outside contour. Now, to create this finishing operation, the Save and Copy button was simply used to create the operation with all the same initial settings. Let's exit the current operation and open the copied iFinish outside operation by double-clicking it in the CAM tree. You'll see that iFinish was chosen for the technology type. The copied geometry, tool, and milling levels definitions are all carried over from the previous iRough operation. On the Technology Wizard page, the default cutting conditions are also used based on a machining level aggressiveness of 6. Now let's switch to the Technology page. Under the Technology tab, the wall island offset automatically defaults to 0 and cannot be changed. Under the iRest Data tab, note that the previous iRough outside operation is selected as the parent operation by default, and the values needed for calculating rest material are populated to the fields. When using the Save and Copy function, the parent operation selection occurs automatically. Let's now click Simulate. First, we'll use the default HostCAD mode to view the wireframe toolpath at work by clicking Play. Then, we'll look at the machining of our part in Solid Verify. Using the slider, I would recommend first slowing the simulation speed down, and then click the Play button. The finishing is performed in a single cutting pass. Well, that just about does it for the outside shape machining. We can close the Simulation Control Panel and the iMachining Operation dialog box with the Exit buttons. Next, we'll take a look at the iMachining operations defined to perform the Through Pockets machining.